I am Neeta. Today's topic is about ABG, analysis and interpretation. Let's get into the topic.
About ABG, arterial blood gas analysis. Arterial blood gas analysis and interpretation that provide information about patient's acid-base status, underlying cause of imbalance, and body's ability to regulate pH. We can see what are the important ABG parameters. pH is one of the important parameter. PaCO2, PO2, bicarbonate, oxygen saturation. These are some of the relevant parameters while dealing and interpreting with ABG. We can see the normal value of pH. Blood pH, its normal value, it is between 7.35 to 7.45. Then the normal value of PO2, it is 80 to 100. Then about the PaCO2, it is 35 to 45. See the relation between the pH and PaCO2 value. There is a 35, there is a 45. In PaCO2 also there is 35 and 45. Okay, so try to understand some similarities between the pH and PaCO2. Let's see what is the normal value of bicarbonate. That is HCO3 minus, it is 22 to 26 milliequivalent per liter. So we can go to the more details now. Now we can try to understand some of the important concepts. What is acidosis? Acidosis means if blood pH that goes below 7.35, it means it is acidosis. Okay. Then what is the another concept? What is alkalosis? Alkalosis means when blood pH that goes above 7.45, it is known as what? Alkalosis. Then what is the importance of the metabolic component? While dealing with metabolic component, you have to think about what? The base bicarbonate. Yes? Okay. When the base bicarbonate increases, the alkali increases, no? So what happened? It is metabolic alkalosis. When the bicarbonate decreases, it is metabolic acidosis. Then what is the next concept? It is respiratory. So while dealing with respiratory component, we can say we have to think about what the PaCO2. So when PaCO2 increases, it is known as what? Respiratory acidosis. Okay, it is what? Respiratory acidosis. When PaCO2 decreases, it is what? Alkalosis. Respiratory alkalosis. Okay, so this is brief about some of the important concepts. Then now we can understand one of the important concept that is known as what? Compensation. So what is mean by compensation? You know what is the meaning of compensation? When there is change in acid-base balance, the body try to regulate the acid-base balance and try to maintain the normal pH by increasing or decreasing the acid and base concentration. That is mean by compensation. In compensation, we can observe in ABG values as if carbon dioxide, that is the PaCO2 value increases, we can see the bicarbonate also increases. It means the bicarbonate and carbon dioxide that moves in same track or in same direction. Understood? It means if carbon dioxide decreases, what happened to bicarbonate? It also decreases. This is what compensation. So in compensation, in case of fully compensated stage, we can observe what the pH is between 7.35 to 7.45. Clear now? Then the acid and base that moves in the same track and pH that is between 7.35 to 7.45. That is what is known as what? Fully compensated stage. In case of partially compensated stage, what we can observe? We can observe the carbon dioxide and also the bicarbonate that moves in the same track. If it increase, both increase together. If it decrease, both decrease together. That we can observe, but pH is not in a normal range. pH is abnormal. Clear no? Okay. So these are some of the concept about the compensation, partially compensated stage, and also the fully compensated stage. Okay. Now we will discuss some problems, some tricks to solve problems. Yes, tricks. Okay, we can go to the topic now, the main area of the topic, that is the problems. The step 1, how to interpret APG. The step 1, that is what? Identify the pH. Yes? Then what is the step 2? In the step 2, we have to differentiate acidosis and alkalosis. Yes? Then what is the step 3? In the step 3, we should differentiate, is it metabolic or is it respiratory? Yes? Okay. Then what is step 4? In step 4, we should identify, is it compensated? Yes, is it compensated or it is non-compensated? So this is the way we have to follow while interpreting ABG. So we can see the first problem. The pH value, it is 7.30. Then PCO2, it is 49. Then bicarbonate, its value is 24. Try to identify. First, we have to see what? It's pH. So what is the value of pH? Is it increased or decreased? That is decreased. It means what? Acidosis. Okay, keep in mind acidosis. Then relate that acidosis with the parameters. See the value of carbon dioxide and bicarbonate. Which one? Which one that indicate acidosis? Carbon dioxide. It increased. So it is respiratory acidosis. Why it is respiratory acidosis? Because carbon dioxide increased. That's why it is respiratory. See the value of bicarbonate. It is normal. It means what? It is compensated or non-compensated? It is non-compensated. Why? Because pH is abnormal. Then one value it changed, that is carbon dioxide increased. Other value, that is bicarbonate, it is normal. That's why it is non-compensated respiratory acidosis. Clear, no? Non-compensated respiratory acidosis. We can go to the next problem. The second problem, pH it is 7.49. Then PCO2 it is 37. Then bicarbonate, its value is 29. Try to interpret pH as a decrease or increased. As increased. PCO2 as normal. Then bicarbonate at increased. Try to identify. pH increased means it is alkalosis. Clear, no? It is alkalosis. Then see the value of carbon dioxide. That is not related with alkalosis. Yes, because it is normal. See the value of bicarbonate. It increased, no? Base increase. It means what? It is alkalosis. What type of alkalosis? It is metabolic. So it's a type of metabolic alkalosis. Clear, no? Then try to identify whether it is compensated or non-compensated. It is non-compensated. Why? One value is stable, then pH it is abnormal. That's why it is non-compensated metabolic alkalosis. I think it is clear, no? Yes. Now we can go to the another problem, the third problem. That is the pH, its value is 7.31. Then PCO2, it is 48. Yes. Then bicarbonate, its value is 29. Okay, try to identify. First, we have to see the pH. Has it increased or decreased? What is it? It is decreased. It means it is acidosis. Yes, acidosis, clear. Relate the acidosis with the parameter PCO2 and bicarbonate. See the value of carbon dioxide. That is 48. Is it normal or increased? That is increased. See the value of bicarbonate. Is it normal or increased? That is increased. Try to identify it. Both value elevate. Both value move in same track. Yes, sure, it is compensated. Okay? Okay. Then you relate with acidosis with the parameter. Carbon dioxide increased. It is acidosis. It is respiratory acidosis. So we can say it's a case of respiratory acidosis with compensation. So what type of compensation? Is it fully compensated or partially compensated? It is not fully compensated. Why? Because pH is abnormal. That's why we can say it is partially compensated. Yes, it is partially compensated respiratory acidosis. Clear, no? In case of partial compensation, compensation will take place. If one value increase, other value also increase. pH is abnormal. That is the meaning of the partial compensation. Okay, I think it is clear, no? Yes. We can go to the fourth problem. That is pH, its value is 7.47. Yes. Then PgO2, its value is 32. Yes. Then bicarbonate, it is 20. Identify the pH, it is elevated. What about it? Elevated means what? It is alkalosis. Yes, it is alkalosis. See the value of carbon dioxide, it decreased. Bicarbonate, it also decreased. Both value, PgO2 and bicarbonate, that goes down, move in same track. It means it is compensated. And identify the value of the what? pH, that is abnormal. That's why it is partially compensated. Okay. Try to relate alkalosis with parameter. See the value of carbon dioxide, it decreased. See the value of bicarbonate, it decreased. It means when carbon dioxide decreases, PCO2 decreases, it is what? Respiratory alkalosis. Clear, no? It is respiratory alkalosis. What type of compensation? Partially compensated. So it's a case of partially compensated respiratory alkalosis. I think it is clear, no? So we discussed non-compensated and partially compensated acid-base imbalances. Now you understand one trick to solve ABG. When pH reached normal range, that is the normal range mean between 7.35 to 7.45, okay, how you will differentiate whether it is alkalotic or acidotic? In case of compensation, pH came back to normal level. It means it is between 7.35 to 7.45, but we have to decide whether it is respiratory imbalance or whether it is the metabolic imbalance. In order to differentiate that, we should know this has acidotic nature or alkalotic nature. So you understand what if the value is between 7.35 to 7.39, it is acidotic. That is mildly acidotic. Okay. And if the value is between 7.41 to 7.45, okay, 7.45, we can say it is mildly alkalotic. Okay. So this is a trick. This trick you have to keep in mind. Next we can go to the another problem. The pH, it is 7.39. Yes. Then PCO2, it is 60. Okay. Then bicarbonate, its value is 30. So try to interpret. 7.39, it means it is normal pH. 60, it is elevated. PCO2, it is 60 elevated. Bicarbonate, it is 30, it is also elevated. It means the both value goes in the same track. It means it is compensation. pH came back to normal level. It is fully compensated. Now we can identify from the pH, is it acidotic or alkalotic? That is the first step, So it is acidotic or alkalotic? It is acidotic. Why it is acidotic? Because this value is below 7.40. Okay, that we discussed. Yes, so it is acidotic. Okay, then the next thing is what? See the value of PgO2, it is increased. So we can say it is what? Respiratory acidosis. Yes, it is fully compensated one. Okay, it is fully compensated respiratory acidosis. I think it is clear, no? Why acidosis? The value is 7.39. Okay, the value between 7.35 to 7.39, it means it is acidotic. PCO2 increased, that's why it is respiratory acidosis. Okay, then bicarbonate also increased as a part of compensation. Why it is fully compensated? pH is normal. Both value elevated. Both together move in the same direction. That's why it is fully compensated respiratory acidosis. Clear? No? Okay. Next we can go to the another problem. pH, it is 7.42. Yes. PCO2, it is 48. Yes. Then bicarbonate, its value is 31. Okay. So try to identify. Yes, you can see the pH. It is normal. Yes, it is normal. Then what we can say, it is alkalotic or acidotic? It is alkalosis. Why it is alkalosis? Because the pH range, it is greater than 7.40. It is between 7.41 to 7.45. That's why it is alkalotic. So it is alkalosis now. Then relate with PCO2 value and bicarbonate value. Both elevated, no? So we can relate it with bicarbonate. Why? Because when bicarbonate elevate, alkali elevate. That's why it is alkalosis. So it is what? Metabolic. It is what? Metabolic alkalosis. Clear? No? Then we can identify whether it is compensated or not. It is compensated, sure. It is fully compensated. Why? Because pH is normal. Then both value elevated in the same direction. So that's why it is fully compensated. So I think the concepts as clear. Yes? Okay. So till now we discussed pH. Yes. pH. Acidosis. Alkalosis. And major acid-base imbalances and how to interpret ABG in brief. I think it is clear, no? You have to practice it. Take more problems and practice. Thank you.